In this video, I am going to teach you the steps for drawing a free body diagram and simplifying it to find acceleration of a given system. The first step is to choose the system such that none of the parts of the system move with respect to each other. So if you take the given mass as your system, then parts of the mass should not move with respect to each other. Next step, label all the forces acting on the system. What we learned in the last video about labeling weight, normal reaction and tension, if that is applicable in your given system, you have to label them all. Choose the axis such that at least one of the axes coincides with the direction of acceleration. Given the direction of force, the direction of acceleration has to coincide with one of the axes that you choose. Label the acceleration, label the direction of the acceleration. Resolve all the forces along the axis. You have to resolve the forces if they are acting at a certain inclination. So resolve them into horizontal and vertical components. And finally, use force equals to mass into acceleration along each of the axes to get equations and to simplify the given numerical. We will try to solve these two examples using the above mentioned steps. Let us start with this one. Now the first step is to choose the system. Now here it is obvious that this block of mass m will be our system. Here this end does not move with respect to the other end. Hence our system is stable and none of the parts move with respect to each other. Then label all the forces. The forces acting on this are weight of the object mg acting vertically downwards. The block is in contact with the given surface, hence normal reaction capital N. Then we choose the axis x and y such that the axis x coincides with the direction of acceleration. We have labeled the acceleration as well. Then resolve into components. Nothing is acting at any angular inclination, hence we can skip that step. Then the final step, along x-axis, force equals to mass into acceleration. This force will provide acceleration A for this block of mass m. Along y-axis, now it is obvious that there is no acceleration along y-axis, hence n minus mg will be equals to 0. Now for this given question, again we use the same steps. First step, it's obvious that this block of mass m becomes our system. Here the given force is acting at an angle theta with the horizontal surface. So the first forces we label will be the weight mg of the object acting vertically downwards. Normal force acting vertically upwards. We choose the axis x and y such that it coincides with the direction of acceleration. Then we resolve the given force into components. Now since this angle is theta, the component of force acting along x-axis will be f cos theta and along y-axis will be f sin theta. Then the final step, along x-axis, what do we have? Along x-axis, f cos theta is providing the given acceleration for mass m. Hence f cos theta equals to mass into acceleration. Then along y-axis, there is no acceleration along y-axis because f sin theta n and mg balance each other such that f sin theta plus n minus mg will be equals to 0. So using this method you can solve this question for a given type of similar numerical. Tune in the next video to see the solutions of questions like a block being dragged on a frictionless slope and two masks hanging with the help of a string. Like the video, leave some comments and subscribe to the channel if you haven't already.